Okay, so we're back. Now, this is a problem. This is why fireworks always, they shoot up in the air, then they come to a stop, and then they explode. Or they're still going up in the air, or this is what they're doing. Okay, so fireworks will come up, kind of pause, reach their maximum height, then explode. So then when they explode, everything goes in a different direction. But the momentum before was equal to 0. And so when we add up all these little bitty pieces and all their vectors, the momentum after will equal 0. Becomes quite a problem, to try and, you got to look at the aggregate. So we're just going to look at a rocket that blows up into 2 pieces. Or if they continue to go and they kind of blow up like this, then they blow up. Well, there's some pieces going to go this way, but the majority of them will go like this. All right. So, but again, the momentum before is equal to the momentum after. So on problem 62, it's a piece of cake. It really, really is. But again, we're going to have a momentum in the x direction, and we're going to have a momentum in the y direction. All right. And so here's how I want you to look at this problem, problem 62. It just kind of came. It just kind of came to me. I need to turn off my Outlook. I am so sorry. Wasting your time. All right, there we go. All right, now, this is the way I want you to set up this problem. All right. So you got the rocket coming in like this. Okay, so here's our rocket where V naught is equal to whatever it is. And then it splits up like this. It blows up. One little piece of mass goes this way at 30 degrees. And one little piece of mass goes this way at 60 degrees down like this. Okay? All right, but the momentum before has to equal the momentum after. And the momentum after, all right, of the entire system. So we look, again, you look at the momentum in the x direction is equal to the final momentum in the x direction. So you'd have your m naught, your initial mass, times its v naught. That's all going in the x direction, so that's all fine because we've rotated it, is equal to m1 times v1 final times x direction part of this vector. What would that be? Cosine of 30. You're right. Plus m2, which I think they give you the masses. And this one's also plus. Cosine of 60, or V2 final, cosine of 60. What do you think we're going to do now? Wait a minute, I've got 2 unknowns in one equation. I need to come up with another equation. Not to worry. It all kind of follows the same pattern. Isn't this great? I love it because it's all following about the same pattern. So now let's do the same thing with y. Ooh, but something interesting happens with the y component. Look. The momentum in the y. What's the momentum in the y direction before it starts? Think about it. Since we've rotated this down, it's all going in the x at the start. So what's the momentum? Right. And then you're going to use your sines over here instead of your cosines. Piece of cake. Enjoy. Out of here.